In this lesson, we will be looking at how to solve radical equations using some of the things that we know about radical functions. So if we have a radical equation, we have two methods we can use. As with any equation, we have two methods that we can use to solve it. So method one, everybody's favorite, is good old-fashioned algebra. Now, in order to do the algebra, we are going to need to use a theorem that lets us do some of the algebra that we need to do. So power theorem says if x equals y, then x to the n equals y to the n, where n is a whole number. So basically what it's saying is if two numbers are the same, then squaring them, cubing them, raising them to the fourth power, or any whole number power will keep them the same. So this means we can raise both sides of an equation to the same power, and our answers should stay equal. Notice, though, this is not an if and only if. And only if. So if it were if and only if, that would mean that if we had x to the n equals y to the n, then x would have to equal y. And we know that's not true. Because if a squared equals b squared, it doesn't necessarily mean a equals b. A could be negative b. If you have 4 squared is the same as negative 4 squared, but 4 is not equal to negative 4. So it only works in one direction. We are allowed to do the same thing to both sides. We can't like take the square root of both sides or just the positive square root because we don't necessarily know what's positive or negative. The other thing to keep in mind is that when we raise both sides of an equation to an even power, this is going to cause us some issues because we might introduce solutions in which one side is equal to the negative of the other side. So when we get a solution, we actually have to plug it back into the original equation and check to see if it works. Otherwise, we might end up giving a solution that doesn't actually work, and we would never want to do that. So how do we deal with this? Well, let's look at an example. Okay, so example 1 says we are going to take radical x minus 1 minus 2 equals 0. Okay, so we have some pretty concrete steps that we can follow algebraically. So step 1 is isolate the radical. So we're going to isolate the radical. So how do we do that? Well, we get the radical by itself. Okay, how are we going to do that in this equation? Well, we have radical x minus 1 minus 2 equals 0. We will add 2 to both sides, so we get radical x minus 1 equals positive 2. Lovely. Okay, now step 2, we isolate the radical. Now we raise both sides to the n power. And the power law allows us to do this. So we can say, because radical x minus 1 is 2, radical x minus 1 squared equals 2. I'm putting the 2 in brackets, 2 squared. No matter what's on either side of the equation, I would have to put the whole thing into brackets. Okay, that might be a little annoying, but you know what, especially when we get to things like the next problem, but it's necessary because we are squaring x and y, which is the whole left-hand side of the equation and the whole right-hand side of the equation, because those are the things that equal each other. Okay, squaring a radical gives me what's underneath. Okay, that is equal to x minus 1. Now some of you might be noting, but not if x was a negative number to begin, or wait, domain issues. For now, we can actually just let that thinking go and just kind of continue with the algebra, and then we'll go back and we'll check our work. The check eliminates the need for too much thinking, but you can, if you prefer, do it using domain and range and then check to see that your answer actually falls in the right domain. So here we get x equals 5. So let's go back and check. Okay, so that was our step 3. And step 3, once we've squared it, is solve. Okay, so if it's a linear equation, you solve it like a linear equation, which is what we did. If it's a quadratic equation, you solve it like a quadratic equation. Step 4 is a check, and it's not optional. This is not your math 9, check your linear equation to make sure it actually works and you didn't make a mistake. You may have done the math perfectly and you could still wind up with a solution that doesn't work. So you need to check. There can be, we call these extraneous roots. So let's see. We have radical x minus 1 minus 2 equals 0. So let's plug in radical 5 minus 1. That's what we're trying to get. We actually can leave off that equals 0. Radical 5 minus 1 minus 2. That's radical 4 minus 2. And that truly is equal 0. So that checks out to what we were supposed to be finding. Okay. Example 2. Okay. This one is a little bit more fun. So let's say we have radical x plus 1 minus x plus 2 equals 0. Okay, so I'm going to start with step 1. I'm just going to write the number here. Step 1 is to isolate our radical. So we're going to isolate our radical. So you get radical x plus 1 equals x minus 2. Now we're going to do step 2, and we're going to square both sides. And you will hear me say this a lot. We want you to square that equals x minus 2. Okay, so we're going to square both sides. And when you do this one on the left, I want you to do it properly, which means you are multiplying bracket x minus 2 times bracket x minus 2. And you can do that in your head. That's fine. I don't need you to show the entire FOIL. I just want you to do it correctly or properly. So that would give us x squared minus 4x minus 4. Sorry, plus 4. Even I need to do it properly. X plus 1. Okay, so now we're going to rearrange the equation. Okay, so number 3, we're going to solve it like it's a quadratic. So get all the numbers on one side, variables on one side, so we get x squared minus 5x plus 3 equals 0. So now I'm going to look and I'm going to say, well, I'm trying to factor this. I don't know any numbers that multiply to be positive 3 and add to be negative 5. That's problematic. So now, is this when we give up and say, there is no solution to this equation? Of course not. Quadratic equations, we have to check more than it doesn't factor to see if there's a solution. And the way that we can solve this quadratic equation, or at least attempt to, is by using our wonderful, amazing friend, the quadratic formula. So if x equals negative b plus or minus the square root of b squared minus 4ac, and put that all over 2a. And if you don't know the quadratic formula, you should learn it. At this point, it's something that you should have as a tool in your toolkit, and it's not in your toolkit if you don't know it. So, we have x equals negative b, that is 5, plus or minus the square root of 25, minus 4 times 1 times 3, which is 12, all over 2 times 1. Okay, so simplifying that, we get that x is 5 plus or minus radical 13 over 2. Clearly that wasn't going to be a nice rational number. However, it seems to be a lovely workable number. So in this case, we may want to sort of estimate what these are. So I know that radical 13 is going to be a little bit bigger than 3, but less than 4. So this is between 3 and 4. Oh no, I don't have my calculator with me. So I need to be able to do a bit of estimation. So how am I going to figure out whether these solutions or any of these solutions are valid? Well, I'm going to go back to my original equation. So I have radical x plus 1 equals x minus 2. What I'm going to do is I'm going to think of what goes in here. This is think of it kind of like a domain. And what comes out here is kind of like a range. That's what's coming out of the radical. So what goes into my radical has to be positive, and what goes out of my radical has to be positive. So let's investigate what are the restrictions on the x's that could solve this equation? Because if it makes my radical blow up, it's not going to actually solve the equation. And if it makes my x minus 2 come out negative, it's not going to actually solve the equation because the radical should only be returning positive numbers. So you know that x plus 1 is greater than or equal to 0. X is greater than or equal to negative 1. Okay, and you are welcome to try plugging 5 plus radical 13 over 2 and 5 minus radical 13 over 2 into your original equation. I just don't recommend it. I don't think that you're going to get it. It will take you a lot of time to do. You can use a decimal approximation. You can try it, but I find this way to actually be simpler despite the fact it requires thinking. Okay, so you know that x has to be greater than or equal to minus 1. Okay. We have x minus 2 greater than or equal to 0. So you know that x also has to be greater than or equal to 2. Okay, so only x's that are bigger than 2 will work. So when I look at this, what I'm trying to figure out is I want things that will make these both have to be true. So all the numbers that are bigger than minus 1, just to visualize this a little, all the numbers that are bigger than minus 1 are going to be this way on my number line, and all the numbers that are bigger than 2 are going to be this way on my number line. So all the numbers that are both are going to be here. So that means we can summarize this as x greater than or equal to 2. Well, let's go take a little bit of an estimation. So 5 minus something between 3 and 4 is going to be somewhere between, well, 5 minus 3 is 2, that would give me 1. 5 minus 4 is 1, that would give me 1/2. It's not going to be bigger than or equal to 2. So we have our 5 minus radical 13 over 2 is going to be too small. It's not going to be greater than 2, so it's not going to work. If we look at our plus, 5 plus radical 13 over 2. 5 plus 3 over 2 would be 8. 8 over 2 is 4. So this one is going to work. You can actually calculate the point. It works out to approximately 4.303. Okay, so we've actually just spent all this time, if we look back up here on method 1 algebra. So why are we not taking more time doing the graphing? Well, graphing radical equations, unless they have real nice points for you, is basically just engaging in a lot of guess and check. So rather than teaching you how to solve an equation by graphing radicals, I'm going to teach you how to solve pretty much any equation. So we are going to solve radical, and when I give you test questions, it's more likely to reflect these understandings I want you to have. Minus x plus 2 equals 0 by graphing. Okay. So what we're going to do is we are going to, step 1 is isolate the radical. You basically want to turn it into something that has a function on both sides. So if we have radical x plus 2 equals x minus 2, just like our step 1. Okay, so what I'm really doing is, if you think about what I have a radical function that looks something like that. Then I have a line, x minus 2, y equals x minus 2. And what I'm trying to do is I'm trying to look for the point where those two things intersect. And you know who can do that a lot better than me? Desmos. So if we want to solve, and this doesn't just work for radical equations, it works for literally any equation. If we have some expression on one side, some expression on the other side, what we're going to do is we're going to graph y equals radical x plus 1. Okay, we take that and we do that, make it a y equals. We take this side and we make it a y equals. Y equals x minus 2. And we look for their point of intersection. We're trying to figure out where those two things intersect. So it's backwards of what you guys used to do to solve systems of equations. So with systems of equations, you would already have the y equals, and then you would set them equal to each other and solve. Here we're taking it backwards and saying, well, what if each side were really a function, and then where's their point of intersection? Okay, and so then we look at the intersection, and we take the x coordinate. Okay, so we have 4.303 and 2.303, and we can do this on Desmos just as easily. On a test, I'd be more likely to show you the graph of each side of an equation and ask you to tell me how your solution relates or something like that. I want you to understand that the intersection point gives you the solution, but the task of actually graphing it works as I don't think it's really worth your while to learn how to do that properly. This is the section, the solving by graphing. Please do not read what is in your workbook. Just ignore it, because I find it to be way more confusing than just understanding that y equals the left-hand side, y equals the right-hand side, point of intersection is your solution. Okay, because he is basically asking you just to pick x's and plug them in and then find it, which is essentially solving the problem by guess and check. Okay, so wait, now I have 2 points, x and y. Which one's our answer? Well, the x is what x is, and the y is what you know how the two sides are supposed to be equal? The y is what they are equal to. So if I plug in x equals 4.303 approximately, I will get on both sides of that equation 2.303, showing that they are, in fact, equal.